G'day, it's Alex here again, Victor Kilo 2 Papa Radio Charlie over here in Australia. Over the years I've put up many videos concerning the 320 power supply. We've talked about things like changing capacitors, substituting modern day components with the ones that are superseded and you can't get any more. I've gone through each and every part of the power supply and explained how they work, etc, etc. But of late I've been aware that there's a new type power supply that was made as a bit of a late addition to the Clansman family, and it's easily recognized by integrated circuits that have been included on the printed circuit board. There's one of these on both of the boards, easily recognizable. If you happen to come across one of these power supplies, you'll notice straight away that the component layout is completely different than the original. In fact, it's a revamped circuit. Very difficult to work on. Absolutely no documentation out there at all. So people that generally come up against these things are really struggling to fix them, and I am for sure. Anyway, look, I was made aware of these particular power supplies when I got one on my bench when I tried to repair it, and come up with all sorts of difficulties, couldn't find any information, put it aside. Time's gone on, and I've been contacted by a good friend of mine in the UK, Mark over there, who tells me that there's been a gentleman in the UK that's done an in-depth study on this new version power supply, and he's put up an absolutely fantastical article in the VMARS Signal magazine. Anyway, his name is Roland Hall, and he's kindly given me permission to share this with yourself and others who watch your YouTube channel. For those that aren't aware, Signal is a quarterly magazine put out by VMARS and stands for Vintage and Military Amateur Radio Society. If anyone out there in the world is interested in vintage radios, it's definitely worth looking at this particular organisation and perhaps joining. So anyway, there's their little ad. But Roland has done this fantastical article on this particular power supply mod. So he's given me permission to bring it to you. So what I'm going to do now is I'm going to go over basically all the findings that Roland's found and how this new addition to the power supply, this variation, actually works. So let's do that. Okay, before we get started, let's just do a quick summary on how the power supply works and some of the common faults that we find with them. Yeah. Okay, so the power supply, everything begins at the 12 volt section of the power supply, at the 12 volt section, right here. And that's the regulating transistor for the 12 volt section. The 12 volt section provides power for the 3 volt section. There's your 3 volt output, yeah. It also goes across and supplies 12 volts for the 6 volt section, yeah. This is the 6 volt section, there's your 6 volt outputs. And the 12 volts gets oscillated via this transistor, step up transformer, rectified and regulated for the 110 volt section of the power supply. The areas that we generally get failure are the 110 volt section of the power supply, probably the most common. It gets reflected back onto this transistor here, the BC, I think it's a BC107 TR3, often fails. The 12 volt section, this particular transistor here, which is the main regulating transistor for the entire power supply, it can fail pretty quickly when you get dramatic sort of pull downs on voltages and increased loads, and I've seen many of those fail as well. Okay, so that's basically how the power supply works. And basically the areas that fail. Oh yeah, I mentioned the 3 volt section here is a common failure point too with the regulating transistors here. So, yep. So let's just dive in now and have a look at the wonderful changes, upgrades that Roland's discovered and how they work. Okay, so let's have a look at the additions that have been added by this particular version of the power supply. As I say, it's easily recognisable by integrated circuits that have been added. And Roland has added all of the new circuitry in red, which makes it really, really easy in his article. And we see here that there's been a couple of extra diodes have been added and a resistor in the output area of the 110 volt regulator. Obviously they've been put in there for extra protection, okay? But the main concern is this particular part of the circuit here, all right? So the whole idea of this particular part of the circuit here is to protect the power supply when we get a problem on the 110 volt output. So if the 110 volt output was shorted or dragged down severely by the radio, by a fault in the radio, instead of blowing the power supply, ideally we'd want the power supply to shut off and not damage itself. And that's why they've put this additional part of the circuitry in here. So let's have a look and see how it works. So we've got an opto isolator here, very, very neatly, strategically put on the board. And if the 110 volts here gets dragged down, current will flow through the opto isolator, illuminate the little LED inside, activate the SCR, which switches on, and the SCR grounds this particular wire here. Now that particular wire goes over to the other board on the power supply. So let's have a follow up and see where that goes. So here it is over here. So it goes onto this part of the board. Remember, this is being dragged down to ground. It goes into the 12 volt regulator into pin 8. And pin 8, if it's grounded, shuts down the power supply, shuts down the output for the 12 volts. So the whole power supply, because everything runs from 12 volts, the whole power supply will just stop. Okay, hence protecting the 110 volt output transistors and protecting the main transistor here on the 12 volt, which is very, very susceptible to failure. I might add too that this particular transistor here, TR3, which is a BC107, extra load on here actually gets reflect back onto that transistor that oscillates for the primary on the transformer. That's an often failure point as well. So that would definitely prevent that. So just in summary again, if the 110 gets dragged down for any particular fault reason, SCR gets switched on, drags this point to ground, which connects to the 12 volt supply into there, and that will shut down the 12 volt regulator that shuts the whole power supply down. So there you go. That's the protection that's been added on the 110 volt section. Okay, as I pointed out before, the 3 volt section is also very susceptible to failure, I've noticed over the years. So in their wisdom, they've decided to put an opto isolator in this part of the circuit on the regulator for the 3 volt side. This time, instead of using an SCR, they've used a transistor opto isolator. So let's have a look how that particular thing works. And it works very similar to what the last one did, but it works all internally on the 3 volt supply. So if we get a drag down here on the 3 volts, yep, the diode conducts, shines some light across here onto the transistor, transistor turns on, there's ground here, transistor turns on, it grounds pin 8 on this integrated circuit that's oscillating madly, making the switch mode for the 3 volt side, and it shuts it down and will shut down the 3 volt power supply. So independent of the overall shutting down of the power supply, if we get a 110 volt fault, this particular 3 volt section operates independently. So just in summary again, if the 3 volts gets dragged down by any sort of a fault, the transistor gets switched on, grounds pin 8, and that shuts down the 3 volt section of the power supply. So there you go, guys. That's the addition of the parts that they've put in this later version of the board. And as we go, there they are again. After this video, at the end of it, I'll put up the full article of Roland's article that he's put up in the Signal magazine. So I'll do each page, and I'll leave it up on the screen for a little while so you can pause this video and copy the page. So as I say, an absolute excellent article that Roland's done, and I'll briefly have a look at that before the end of the video. Okay, here's Roland's complete article. It runs over 3 pages. He's got the circuit diagrams with the alterations. He's got the new board layouts. Yeah, he's got the voltages that you should expect to find on the tag voltages on the links between the boards. He's got testing individual power supply boards, and it just goes on and on with full explanation of how the circuitry works, etc., etc. An absolutely fantastic article. But Roland also acknowledges, get a bit of a focus here, acknowledges thanks to Martin Owen, Golf 4 Juliet Sierra X-Ray, for highlighting the lack of information. So it wasn't just me who was complaining about no information. Obviously, Martin's brought it to Roland's attention. And also my mate Mark Pithaway there, he's also got an acknowledgement there for supplying the power supplies for Roland to examine and create this wonderful article. So thank you very much, Roland, for your efforts. And as I said, I'll put up the page by page of this article right now. This is Alex, Victor Kilo 2, Papa Radio Charlie saying 73. Good luck and good repairs, guys.